Hi everyone, welcome to the second lesson for topic 1, forces and equilibrium. So for today's lesson, we are going to look at forces in equilibrium, alright? So meaning that we are going to understand the principle that when the particle is in equilibrium, the sum of the forces that acted on the point is actually going to be zero, okay? And it's the same thing when we say that the sum of the components in any direction, it will eventually become zero. Okay, so that's the idea. Basically, the notes part for today is pretty little. So we're going to spend more time to actually apply that into question. And other than by using the solution for resolving, we'll be looking at two other methods as well, which is known as the triangle of forces and also Lami's theorem. All right. So these two methods are not required. So meaning that you can always use resolving your components to actually get the answer. But yeah, as you go through the past year paper, sometimes you will see there's an alternative method. So yeah, to prevent that you feel like, hey, how come I didn't learn this before and so on, then I'll just go through with you guys. Yeah, so but don't worry if let's say until the end, then you realize that, hey, by resolving is actually easier, then you can just move on with resolving. Yeah, okay, but I think it's good that you have like extra knowledge on this. All right, so let's start with the introduction. All right, forces in equilibrium. So a body and the forces acted upon it, so meaning the forces are acted upon the body. So this body is in equilibrium if the body is at rest, all right, or is moving with constant velocity. Okay, so the idea is, yeah, let's try to use the situation of at rest to actually understand it. So yeah, we will say that the forces is in equilibrium. If let's say there are many forces that apply on the body, but at the end there's no change in the motion of the body, so that's why we call it as forces in equilibrium. All right, so it's that simple. So that's why in equilibrium the resultant force is actually zero. So it means that there's no resultant force, so that's why there's no change in motion. Okay, and in this state, we call it as forces in equilibrium. Okay, so now we'll be looking at two examples before we move on to triangle of forces and Lami's theorem. Sorry that I try to arrange the notes like what you received today. Yeah, because I think that it's good that we try to put example and our working in one page, so that's why I couldn't find a better way to actually arrange the notes. So that's why I have all the notes in the first page. Then after that, example beyond it. All right. So that's why forces and the first part we'll be looking at the first two examples. Then after that, we'll come back for the notes again. All right. So yeah, let's go to example one. All right, number one. So as we go along, you'll realize that you will use a lot of knowledge of resolving, okay, and some part of trigonometry that you have learned before. And also, what we are trying to do is always solving equation, okay? So what is that? So because previously when we was learning how to find resultant force, right? It's always that you are given the situation. After that, maybe the question want you to find the resultant. So in that case, it will be you are using the information that's given to find your final outcome. Okay, but in this case, you can realize that if let's say all the forces are in equilibrium, right? So basically, you already know that the resultant force is zero. Okay, so that's why in all this kind of question, what you're actually trying to do is solve the equation and to get some of the unknowns. Okay, so yeah, that's the idea of the question. Okay, so let's try to look at it. Yeah, so this is a past year question from paper May June 2020, paper 4.3. So yeah, so four coplanar forces of magnitude 40 Newton, 20 Newton, 50 Newton, and F Newton act on a point in the direction. So this is the point. Lah. So in the direction shown in the diagram. So the four forces are in equilibrium. Okay. So since we know that the four forces are in equilibrium, so meaning that no matter at which direction you are looking at, all the net force or the resultant at the component will always be zero. Okay, and then as the resultant force for the whole diagram will be zero as well. So what we try to do is do exactly do what you need to do exactly like when you try to resolve the force. Okay, so first one, we can try to resolve it in the direction of x first. Okay, so same thing, let's try to make our right hand side to be positive. Okay, so we know that after we resolve into the x component, then we will be getting our answer as 0, okay, because they are in equilibrium, right? Okay, so now let's try to resolve it. So we have the first one, 40, then 60. So 40 cos 60 plus 20 cos 30. Okay, and the other side we have this f cos alpha, so this is what we want to find. Then after that, minus another one, which is 50 cos 45. Okay, so yeah, as you try to go through, you can see that cos 60, cos 30, cos 45 are actually all special angle. So if let's say you want to use your calculator to actually get the value first, you can actually do so. Okay, but yeah, I'll just keep the value first. So we try to arrange our unknown to be at the left hand side. So f cos alpha will be equal to, so meaning that I'm trying to move this to right hand side, then I try to just rearrange the order lah. Yeah, you should be able to understand what I'm doing. So yeah, so 40 cos 60, then plus 20 cos 30. Oops, I'm sorry, 30. Okay, minus 50 cos 45. So this will be my first equation. Okay, so I'll just leave it there. All right, because there's two unknowns, so you can imagine that what I'll be dealing with later is like two simultaneous equation. Okay, so now after we resolve in the direction of x, let's try to resolve it in the direction of y. Okay, so maybe going up is a positive one. All right, so by looking at this diagram, then you will know that you have 40 sine 60. Yeah, I hope that by now you should be very familiar with how to do this sine cos thing, right? Okay, 40 sine 60 and then plus f sine alpha minus 50 sine 45 and minus 20 sine 30. Okay, and similarly, the resultant is 0. Okay, so same like equation 1, let's try to arrange our unknown at the left hand side. So f sine alpha will be equal to, so 50 sine 45 plus 20 sine 30 and minus 40 sine 60. Okay, so this is our second equation. So now by having these two equations, then we are going to solve it. Okay, so you realize that it seems to be like very complicated. So how am I going to do with this? Okay, so we have f cos alpha, f cos alpha and also f sine alpha, right? So from here, then the thing that we can try to do is, I mean, of course, you can try to bring this over the other side. Then after that, you substitute f. Okay, but an easier way to actually do that is we already know that sine divided by cos is tangent. So that's why you need some amount of trigonometry knowledge here, so to help you to solve the question easily. So that's why we can always use our equation 2 to divide our equation 1. So meaning that f sine alpha divide by f cos alpha. Okay, and later it will just give us tangent lah. So it will be equal to, so let's try to copy everything first. Okay, so now let's use our calculator to actually help us to solve this. Alright, so after you have actually get this answer, so you can just copy it in the equation first. So it's like 5.452. Okay, so we'll just continue to use our calculator to shift tangent. Okay, so to get our answer, so it's 79.6. Okay, so yeah, one decimal places, one decimal place if you were to right angle. Okay, so 1 dp. Okay, so yeah, you might want to keep your answer in your calculator in this, yeah, because you are going to use this to continue to solve for your f, right? Yeah, so to make sure that you have the non-rounded angle so you can get your answer more accurate. Okay, so yeah, maybe I can try to teach this once. So this is very helpful in if in future you have actually more than one value to actually keep it in your calculator, right? Because sometimes when you try to press this answer, then you might need another answer, then you can move on for the other solution. So to keep our answer as accurate as it is, so there's one function in your calculator actually called as store. So what you can try to do is after you get this answer, then you try to shift then store. Okay, then in your calculator it will come out this function as store. All right, then what you try to do next is you can try to see there's an a b c d e f. So all this unknown is actually the unknown that to help you to store your value. So which means if let's say now I try to store 79.6, maybe I try to set it in A in my calculator. So which means what I can do is I just press this one. So answer, okay? Then oops, I'm sorry. So again, shift store. So this is my answer. So I can straight away press the A, then you will see answer go into A. So which means that answer is stored as the value A now. Alright. So which means that later when you try to have your calculator, right? So you just press alpha A. So A will represent this number that you store in your calculator. So it will be easier that you don't need to, I mean, if let's say you have more than one answer that you will keep, then you later you don't know how to get the accurate value already. Okay. So this is what we can try to do. So A to F, you can store up to 6 number as you want. Okay. So yeah, after you have this, then now we can move on to actually find our F. So you just substitute into any equation that you like lah. So for example, go to 2 also can, go 1 also can. Okay, so number 2, so perhaps we can try to use 2. So meaning in this case, then f sine. So here you can still write the one decimal place, then but in your calculator, make sure that you are pressing it in full. So 45 plus 20 sine 30 minus 40 sine 60. Okay, so you can just have everything here. Then after that, f will be equal to, okay, so then you can just use your calculator to just continue to solve it. All right, so yeah, remember that's your A, right? So you can just press the whole thing here. So 50 sine, yeah, so it's a similar thing like what if let's say you already know that at the end you are going to press this again, right? You can just uh press this press maybe you press this whole thing first, then you store as A, then you press this whole thing, then you store as B, then after that you just use A divided by B, then after that at the end you don't need to press it again here, you get what I mean? Yeah, so sine 60. Okay, so you divide by the number that you want is sine this number, right? So since this is the one that you already round it, so we try not to use this, but we already store this value in our calculator, so it just sine then alpha A. So this is the A value, the uh non-rounded angle that we have just now. Okay, so yeah, after you got this, then you should be able to get 10.9. So 10.9 Newton. So this is in 3SF. Okay, so this is how you get your answer. So another alternative way that you can try to do number 2 is to find the f is actually by using the trigonometry of sine square plus cos square is equal to 1. So which means as you try to go along this, right, you will be able to see if let's say I try to square 1, then I'll be able to get f square cos square. Then here I'll be able to get f square sine square. So when I try to add them together, then I try to do factorization, then what I'm actually getting is like, so I'm just going to do the left hand side so you can proceed it by your own if let's say you want to try this out. So which means what happened is like it will become F square cos square. Okay, then after that plus F square sine square, right? Okay, so this will be equal to the same thing lah. Your right hand side, the whole thing you need to square it, then the whole thing here you also need to square it. Okay, don't worry about it because this is eventually just numbers in your calculator, right? It's not like expansion and so on. So yeah, it will be just an easy one just to square it. So after you do this, then actually what happened is you can just do factorize, right? So cos, yeah. So sine square alpha and cos square alpha, we know that it will actually give us 1. So that's why f square will be just equal to whatever that you try to square here. Okay, so this is by, if let's say you don't want to do tangent and you want to find f first, then this is what you can try to do lah. Yeah, okay. Okay, so let's try to look at the actual question here. So state the magnitude and the direction of the resultant force at the same point if the force of 40 Newton is removed. Okay, all right, so let's go back to the diagram. So which means that now all these forces is in equilibrium, right? So if let's say I remove this 40 Newton of force, so what happened to this system is that you already know that all these forces wouldn't be in equilibrium anymore because one force is removed. Okay, but how can we actually find the resultant force in a much more efficient way? I mean, obviously you can just try to resolve everything into x direction, y direction, then you try to find the resultant like how you did previously. Okay, so but with this idea of, if let's say you add in 40 Newton, these forces are in equilibrium, is there any much more shorter way that we can try to do? Okay, so let me try to explain it in this way. Okay, so now right, you can imagine that these forces are in equilibrium. So which means when we try to solve just now, right, we always say that when we try to resolve to the x direction is equals to 0, right? So which means that the right hand side, the force in the right hand side here is actually the same with the left hand side of the force here. Okay, so when we try to resolve to y equals to 0, so which means that the forces acted upwards and the forces acted downwards is actually the same. So that's why when you try to add them together, you will get 0, right? Okay, and if you can recall from the notes above, right? So just now we mentioned that the sum of the components in any direction is always 0 as well. So which means that if let's say now we try to imagine that if we try to resolve our forces here in the direction of 40 Newton, okay, so can I say that, meaning that if these forces are in equilibrium, so meaning there will be equivalent forces on the opposite side of this 40 Newton as well. So which means in another hand, right, all these three forces, after we resolve it, it will actually give me this resultant. Then only it can be equivalent with what happened here so that I can get my answer. So which means in another words that if let's say now this 40 Newton is removed, so which means if just now all the forces are in equilibrium, right? So these three forces will actually form a resultant at the opposite side, which means it's going to be 60° as well and also 40 Newton. Okay, I hope you get what I mean. So that's why when 40 Newton is removed, the resultant force of the three forces left here is eventually 40 Newton and is clockwise, yeah, and it's clockwise from the negative x-axis. Okay, yeah, so that's the idea. So meaning that it's going to be the same thing as well. If let's say now what happened is I try to remove this. Okay, so because these forces are in equilibrium, so which means that I can say that I will always, so these three forces, okay, is actually equivalent with this. So that's why their resultant of these three is basically going to be here, and then this is the 45, and then it's 50 Newton as well. Okay, so yeah, I hope that you can get the idea. So that's why in this case, we are looking at 40 Newton is removed. So previously in forces in equilibrium, so to actually balance this out, So they will have the forces, the resultant forces that actually resolve by these three force to be at this direction of 60 and then 40 Newton. Okay, so that's why in this case, my answer of the magnitude will just be 40 Newton. Okay, and the direction is clockwise from negative x axis. Okay, I'm sorry. So what's the angle just now? Yeah, 40 Newton and 60 degree. 60 degree clockwise from the negative x direction. Okay, so yeah, I hope that you can understand the idea. Okay, so now let's try to look at one more example before we move on to the Lami's theorem. Alright, example 2. So yeah, this is from May June 2020 as well, but it's from paper 4 too. Okay, so yeah, there are four core planar forces of the magnitude of 20 Newton, P Newton, 3P Newton, and 4P Newton acted on this point. Okay, so this system is in equilibrium. So that's why when I try to look at this, find P and theta is actually solving equation as well. Okay, so it's similar, but then it's different in a way that just now the unknown f that you find just now is referring to one force. So now the p that you want to find is actually they use this unknown in like three different forces. Okay, so right, let's try to solve it like how we solved it just now. Okay, so now I'm going to introduce you another way to write it. So just now we write it in a form of resultant in the direction of x equals to 0, right? So another way that we can try to do it is, since that we already know the when you try to resolve in the direction of x, right, you are getting 0. So in another words, which means that we know that when you try to resolve to the right hand side and you try to resolve to the left hand side, it's going to give you the same force. Okay, so that's why what we can try to do is, if let's say now I were to resolve in the x direction, so which means that my right hand side here, what do I have? I have this 20 cos theta, right? Okay, so it will be equal to my what I have after I resolve my left hand side. So which means it will be equal to 3p cos 30 and then plus p cos 30. Okay, so yeah, you can see that it's actually the same idea. If let's say I try to move it to my left hand side, right, then what do I get? I get like the right hand side minus these two, I get 0. So it's actually the same idea. It's just that you straight away write it into like left and right the same. Okay, yeah, so just now the previous question we try to write like after you use your right hand side as positive, then you minus off the left hand side, then you get 0. So it's just the same. Okay, so let's try to just simplify it a bit. So like what we have here, so 20 cos, so I can just, yeah, 4p, since they are both cos 30, right? So 4p cos 30 is equal to 20 cos theta. Okay, so this is our first equation then. All right, so now let's try to move on. So resolve to the y direction. So similarly, we try to do that going up and going down is the same. So which means going up, we have 4p, okay, and then plus 3p sine 30. It will be equal to p sine 30 plus 20 sine theta. Okay, so I hope that you are all right. So let's try to simplify it as well. So yeah, so what we have here is, you can see these two, we can combine them together. So I get minus, so it's 4p and then plus 2p sine 30 will be equal to 20 sine theta. Okay, so you should be happy to look at this side, because yeah, eventually it means that we can just use tangent to solve as well in this question. Okay, so yeah, so after we get this, so which means number 2 we can divide by number 1. Okay, so yeah, by having this, then yeah, but then what you can realize here is that okay, it's okay, let's try to continue first. So 20 sine theta divided by 20 cos theta, okay, will be equal to, so 4p plus 2p sine 30 divided by 4p cos 30. Okay, so you have pp, so which means you can actually just factorize it lah. So 20 divided by 20 no more, so tangent theta will be equal to, so in this case I can take out my p, right? So p, then I have 4 plus 2 sine 30. Okay, yeah, so please be careful like how you solve lah, so try to make it in like a much accurate, like much organized way, so you don't implement the wrong thing here. Okay, so after you get this, then which means pp you can actually just eliminate it, right? So the other thing that you can just try to use your calculator to actually to help you to solve it. Okay, so by having this, let's try to look at our calculator. Yeah, so what I can try to do is I just shift tangent. Okay, then I try to put in my 4 plus 2 sine 30 and then divide by 4 cos 30. Okay, so shift tangent the whole thing. So this is how I get my what is that, my angle here. So similarly, you might want to just store this, or I think this question you only need this, so it's actually still okay. So 55.3 degree, 1 dp as well. Okay, so after we get this, then similarly, we can just try to use our equation 1 to help us to get our answer, I guess. So number 1, so 4p cos 30 is equal to 20 cos theta, so our theta is 55.3. Okay, so which means just bring over what you have lah. So alright, so yeah, we have this as our answer. So just cos our answer and then multiply 20 divide by 4 cos 30. Okay, and we'll be able to get our answer is 3.29. Okay, so I think this is very straightforward. So yeah, it's the same thing as well. If let's say you want to try to do square, okay, so which means that you just try to use the idea for your first one, square your second one, then after that you solve your p first lah. Yeah, but I will always say I feel that by solving tangent is actually easier lah, because if in that case then you might need to rearrange the whole thing and you need to make sure that when you are doing the square you don't have anything that's wrong. Okay, so if let's say you want to solve p first, then you will be using the trigo identity that sine square theta plus cos square theta is equal to 1. So by having this, then you are eliminating your theta, then you can try to solve your p first. Okay, so this is like the alternative way that you can actually solve it. Okay, so now let's try to move on to the part where we want to discuss about the force in triangle. Okay, the triangle of forces, I'm sorry, and also the Lami's theorem. Okay, so like what I say, this is like an extra knowledge for you. So if you are very comfortable with resolving the forces, just go ahead. Okay, yeah. So personally, I actually prefer that as well. But in some case, you can see that this extra concept will actually brings you an easier approach, yeah, in some question. But please note that for triangle of forces and Lami's theorem, right, you can only use it if let's say you are given a situation where the equilibrium has three forces. Okay, so which mean in the example just now, like example 1 and 2, you have actually more than three forces, then you cannot apply these two concepts. Okay, so yeah, you must remember that this only apply to the equilibrium with three forces only. Okay, so let's try to explain it. Actually, this idea is quite straightforward and it's quite easy as well. So yeah, don't worry about that. Okay, so what we have now is, if let's say this is our this is the diagram that's given. So these three forces actually forms a forces in equilibrium. Okay, so let's try to draw the force diagram in the form of triangle of forces. Okay, so maybe we can try to use back the direction for B here. Let's start with B. All right, so what I have here is a vertical line. Okay, so this is my B. Yeah, sorry, I think it's a bit, yeah. Okay, so this is my B. Okay, it's better now. All right, so let's try to connect it in a triangle. So my A is here, so perhaps I can try to draw it like this. Okay, so this is my A. Okay, so which means C is going down, so I can just connect it here. All right, so I have my ABC here. Okay, so now what I try to do next is I try to just write down the angle. We try to denote the angle here. So perhaps for the angle that is opposite of the direction of A, we try to denote it as the small a letter here. Okay, then after that, opposite of B, so this is B, then opposite of C, this is C. Okay, so let's try to find where is our ABC in this force diagram. So this is C is the angle between A and B, right? So that's why this is B. And if let's say I try to extend the A part here, so you can actually see that the C is actually here. Am I right? Okay. Then after that, this is the angle that from A and C. So that's why if let's say I try to extend the C part here, then you will actually see that this is the angle that is actually the same with this. Okay, so this is my B. Okay, so similarly, if I try to extend my B here, then you'll be able to see that from B to actually from B to C, and this is my angle of A. Okay, so if let's say we try to find what is the angle inside, right? So what is this? So this will actually be 180 minus A, right? So this is 180 minus B, and this is actually 180 minus C. Okay, so before this we already learned sine rule, right? So if let's say we try to put this in a sine rule, then what happened is that A over sine 180 minus A. Am I right? That's the first ratio. So A and 180 minus A. It will be just equal to B over sine 180 minus B. Okay, so similarly, I also have my C here, which is opposite of the angle of 180 minus C. So that's why C over sine 180 minus C. Okay, so this is what we call as triangle of forces, and this is the rule of it. So meaning that we try to redraw the force diagram in a triangle of forces, then what we try to do is we try to assume as if the forces is the length in the triangle. Then after that, we can actually try to find the angle inside the triangle. Then after that, we use sine rule to actually help us to solve this. Okay, Lami's theorem is then another theorem that actually they continue to it's like after you draw the triangle forces, then you try to change this a little bit, then this is how you get Lami's theory. Okay, so now by looking at this, so we know that when we try to learn trigo, right? So what is 180 minus alpha is like over here. Am I right? So this is 180, then this will be the 100. Okay, no, let me try to rephrase my word. Okay, so if let's say this is our quadrant, right? So if this is my theta, okay, so I know that for sine, right, Q1, Q2 is, I mean, the ASTC that you learn. So for the first quadrant and the second quadrant, so it's just going to give you the same sign. If let's say I have the same reference angle, which is theta here, am I right? So that's why when you try to press your calculator, when you try to press, for example, sine 30 and sine 150 is actually giving you the same answer because both of them has the same reference angle, which is 30, and then quadrant 1 and 2 give you both sine as positive. So that's why since sine theta is equal to sine 180 minus theta, so that's why we can always try to change this rho to be A over sine A, okay, equal to B over sine B, and then equal to C over sine C. So which means in another words, right, when I try to solve this, except by using resolving, what I can try to do is it will actually give me a formula by using Lami's theorem, is that the ratio of A over sine A will be equal to the ratio of the force B over the sine B. Then it will be also equal to the forces over the sine C here. Okay, so Lami's theorem states that for a particle in equilibrium with three forces on it, the ratio of the magnitude of the force with the sine of the angle between the two other forces, so which means A, and the sine of the angle between two other forces, which is the small a here, the ratio will be the same for each forces. So that's why you can just remember that A over sine A is equal to B over sine B, and then equal to C over sine C. Okay, so yeah, you can see that it's roughly the same like what we have in sine rule, like so-called the triangle thing, but the things that we try to apply is actually a different thing lah. The angle that we try to see is actually the diagram like this. Okay, so now we'll be looking at the past year question, and we'll use one question to actually show you all the three way. Like the first one, how do you solve it by using resolving? Then how do you solve it by using triangle of rule? Triangle of forces. Then the last one, how do you solve it by using Lami's theorem? Okay, now let's move on to example 3. Right, example 3. So this is a past year question from paper May June 2018, paper 4.2 also. Okay, so yeah, I feel that maybe after this example, then you'll feel like it's good to just move on with resolving. Yeah, but like what I say lah, this is like extra knowledge for you. If let's say I mean there's any case in the exam where you forget, or it's like you try to check out your answer, then you can always use like this extra knowledge that you have, right? Okay, yeah, but the idea is to expose you to different approach. So when you try to look at the marking key, then you wouldn't feel like, how come I didn't know this at all? Okay, so the three core planar forces shown in this diagram has a magnitude of 3 Newton, 2 Newton, and P Newton. So given that the three forces are in equilibrium, find the values of theta and P. Okay, so yeah, you can see that in this diagram you have only three forces. So that's why only the triangle of forces and Lami's theorem can be applied here. Okay, so for the previous cases like example 1 and 2, you can only use resolving. Okay, so now same thing, let's try to do resolving first. Okay, so resolve in the direction of x. I think we can go a little bit faster for this because we already know how to do it. So 2 cos theta, and then it will be just equal to 3 cos 60. Yeah, I think this one is super easy. Yeah, right hand side, left hand side is the same than P, since it's perpendicular and you don't need to do anything about that as well, right? So which means you have only one unknown here that you can straight away solve it already. So cos theta will be equal to 3 cos 60 divided by 2. Okay, so just by using your calculator, and you will be able to get theta is equal to 41.1 degree. Okay, so you can either store your value, or yeah, I mean if you're confident enough, you still have your answer as this one, then it's all right lah. So resolving to the r direction, so we have P, then the other one, so it's like P will be equal to, so we have 2 sine theta. Okay, so theta here is 41.1, right? So we can show away 41.1, and then plus 3 sine 60. Okay, so after we got this, then we can show away use our calculator to solve, then you will be able to get 3.92 Newton, so in 3SF. Okay, I think this question is pretty simple. Yeah, so you can see it's like a 4 marks question only, because by resolving one, you actually can get one unknown already. So you don't need to like solve the simultaneous, which is like harder, like the trigo part. Okay, so now let's try to use the first extra approach that we have learned just now, the triangle of forces. Okay, so which means if let's say you want to do triangle of forces, right? Let me try to write it. Okay, so if we want to use triangle of forces, the first thing that you need to do is actually draw the diagram of the triangle. So which means in this case, I think it's not that hard because you have the P, which is just a vertical one, right? So we can always start with that. So we have P that's going down. Okay, then after that, the other way we can just continue with our 2 Newton here. So we can draw it as a shorter one. Okay, so this is the 2 Newton. Then after that, we have the longer one, which is from here to here is 3 Newton. So that's why from here to here is 3 Newton. Okay, then we can try to just expand the line like how we do just now. So we do it for P. Oops, supposed to be a vertical one, sorry. Yeah, so I mean, don't worry about, so it will be easier that every time you just try to extend it from the part you draw your arrow, then you don't confuse yourself. Okay, so in which means I try to extend it here, I try to extend it here, I try to extend it here, then it wouldn't be anything wrong there. Okay, so then we can try to check one by one. So you can see this is like the P, then this is like 2, right? So what we have is this. So this angle here is basically equal to 90 degree plus theta. Am I right? So here to here. So this is 90, right? So 90 plus theta. After that, move on to the 2n and the 3n. So 2n and the 3n. So the angle actually between them here is actually the angle here, right? So how am I going to do get that? It's going to be 180 minus 60 minus theta, right? So this is how I get 120 and then minus theta. Okay, so similarly, then I can try to look at this part. So this part is between P and also between the 3. So 3 and P. So which means in this case, then it will be my 90 and then plus 60. So this is 150. Okay, so after I get this, then I can actually find what angle do I have inside. Okay, let me try to use the other color so it isn't that confusing. Okay, so 150 and then what I have inside is 30. Okay, so this part I have 90 plus theta, right? So which means when I try to use 180 to minus this, then what do I have? Then I will have 90 minus theta. Okay, so similarly for this 180 minus 120 minus theta, then I'll be able to get 60 plus theta. Okay, so by having this three, then I can apply the sine rule for triangle inside this diagram. Okay, so which means that what you can try to do is you can try to state everything. Then after you state the whole thing, right, then you just pick whenever two ratio that's helpful for you to solve. Okay, so which means in this case, maybe we start with P. All right, so P and 30 plus and 60 plus theta is actually one pair. So that's why P over sine 60 plus theta, okay, it will be equal to, we have 2 and 30, right? So that's why 2 per sine 30. And the last one is for the 3 Newton, and the angle opposite it is 90 minus theta. Okay, so by looking at this, then which means that the one that you have all information is actually this. So you can always try to take this first so that you can try to solve your theta. So after you solve your theta, then only you try to solve P. So which means that I have 2 over sine 30 is equal to 3 over sine 90 minus theta. Okay, so which means in another words, I have sine 90 minus theta, it will be equal to 3 sine 30 divided by 2. Okay, so I hope that you can get up to this point that 90 minus theta will be equal to. So I can just use my calculator. All right, so yeah, let's continue with this. Okay, so 3 sine 30 and then divide by 2. Okay, so I can straight away shift sign my answer. So I can get 48.59. So we can just write 2 degree here first, sorry, 2 decimal place here first, then after that, let us continue to solve. So 90 minus my answer. So I'll be able to get 41.4. So you can see it's the same answer as what we got here. Okay. But yeah, you'll definitely think that just do resolving is easier. Yeah. Okay, so the idea is because of this diagram, maybe some of the angle is actually quite complicated. So that's why when you try to solve the theta, then you still need to minus 90 and so on. So this is why by doing resolving is easier. But in some cases where you will have the triangle of forces or Lami's theorem easier as well. Okay, so same thing. I think I don't continue here. Basically, I'm just getting this part lah. Then you substitute your theta here. Then you can just continue to find your p. Is it all right? Okay, so now I'm showing you the third way, which is by using the Lami's theorem. Okay, so maybe I try to use another color again. Okay, so or this is by using the idea of Lami's theorem. Okay, so for Lami's theorem, it will be easy because you do not need to redraw this diagram again. So which is just by looking at this. Okay, so which means that we might need to find the angle between, okay, let me try to use this, between here, okay, because this is between 3 and 2, right? And what is this and what is this? So that's the idea. So this is 60 plus, okay, maybe let me try to redraw this, then it will be easier for us to look at it. So I have this, this, and this. Okay, so this is my 3 Newton, my 2 Newton, and my P Newton. All right. So after I have this, right, then which means that by looking at the diagram just now, I know this is 60 and then plus 90, so this is 150. Okay, and then here I have 60 and theta, so that's why to find the middle one, then I use 180 to minus it, right? So after I use 180 to minus 60 minus theta, then I will be able to get here as 120 minus theta. Okay, then the last one is here. So here, which what I have here is 90 degree and then theta, so that's why it's just 90 degree plus theta. Okay, so Lami's theorem, it will be easy because what you try to do is you try to look at the opposite one, then you try to get it. So which means that P will be over sine 120 minus theta. Okay, yeah, P and the angle opposite it. So similarly, I have 2 over sine 150. Then I have the third one is 3 over sine 90 plus theta. Okay, so yeah, this is not that tricky like what you have here because this one you will need to actually draw it, then you need to find the angle. So this one is just by putting them into ratio lah. So similarly, by using the same idea here, so you can just take this, then after that you try to solve it. So you can try to see, right, when you try to do this, it's actually the same, the roughly the same thing like this. Because what you have is like 2 over sine 30, so we know sine 150 and sine 30 is actually the same thing. Then sine 90 plus theta and sine 90 minus theta, right? Eventually, you will get the same reference angle as well. Okay, so when you try to just continue to solve it, then you'll be able to get the exactly same answer also. Okay, so I hope that you can just get the idea. So let me try to just quickly write down the working here if let's say you want to try it out. So which means that I can actually take this part first. So 2, oops, I'm sorry. 2 over sine 150 is equal to 3 over sine 90 plus theta. Okay, so sine 90 plus theta will be equal to 3 sine 150 divided by 2. So from here you can actually see a tricky part. So this is why I want to just show you, to prevent that you find it confusing. How come you will have a negative theta here? Okay, so the idea is like this. So you must make sure that later when you shift sign your answer, right? Okay, because we know that, for example, when I normally, if let's say I try to solve for, let's say sine theta is equal to 0.5, okay, like 1 over 2. So when I try to solve theta, right, if let's say my theta is like from 0 to 360, then what do you need to do? You will have 30 and also you will have 150. Am I right? But just that in this case, we are not taking the other side because we know that 90 minus theta, when we try to look at the angle here, this is an angle that is in the first quadrant. So that's why when we try to solve this, we straight away get 48.59. But when you try to look at this question, right, do you think that you can actually get the first one? Okay, so which means, for example, let me try to just press it in calculator first. Okay, so when I try to solve this, then what do I get is that shift sine, then after that 3 sine 150, okay, and then over 2. Okay, so when you try to solve this, right, what you realize here is you got 48.59. So my problem here is, do you think 48.59 is a logical answer here? So which means you can imagine that you are saying 90 plus theta is 48.59. By just looking at this picture, you already know that 90 plus theta should be an angle in second quadrant, right? So that's why in this case, which means that when you try to solve 90 plus theta, right, when you try to shift sign your answer, you actually have two answers. So the first one is 48.59. So the other one is the angle in second quadrant, which is 180, then minus your 48.59, which you get 131.541. And because of we know that 90 plus theta got to be a number that is in second quadrant, right? So that's why we just try to take 90 plus theta is equal to 131.41. So by solving this, then now you'll get a positive answer, which is 41.4, which is exactly the same thing like this. Okay, so after that, then the P1 will be just the same lah. Then you can just try to continue by yourself and get your P, and you'll realize that it's actually the same answer like you're resolving. Okay, so I hope that you can actually try all these three approach by yourself. Then after that, to understand what's their difference, then I mean in the future, then you can try to actually identify yourself like which one is easier and which one you want to use. Okay, so now let's try to look at the last question before we close this lesson. Okay, number five. So I think this is an interesting example for us to go through together, and at the same time, I just want to show you the different way of resolving it. And in this question, actually, by solving with Lami's theorem, it will be kind of easier as well. So yeah, that's why I think it's a interesting question for us to discuss. Okay, so perhaps let's try to go with resolving first, and you try to see. Okay, let's try to do Lami's theorem first, maybe, because in this case, I think Lami's theorem is much more easier. Okay, so because why is that so is because you can definitely already realize that you have one complete pair, which is 50 Newton and also 120 degree. So similarly, you have 40 Newton and alpha is the angle that you want to find. So which means the first ratio that I can have here, right, is definitely going to be 50 over sine 120, and then it will be equal to 40 over sine alpha. Am I right? So by having this, then I can actually solve my alpha already. Okay, so my sine alpha will be equal to 40 sine 120 and then divide by 50. Okay, so yeah, this is something that you need to be careful again because by looking at this picture, this alpha should be an angle that is more than 90 degree. So that's why when you try to solve your alpha, you will have 43.8 and also 136.1. Okay, so because of our alpha is greater than 90 degree, so that's why the one that we try to take here is 136.1. Okay, so by having this, then what we can try to move on now. So is that we have our f, so which means we have our alphas. Then if let's say we try to denote this as our beta, so we can find our beta now, right? So our beta will be just equal to 360 minus 136.1 minus 120, and that gives us 103.9. So by having this, then I can set up the other ratio, which is f over sine 103.9. It will be just equal to 50 over sine 120. Okay, So just by moving sine 103.9 to the other side, then I'll be able to get F equal to 56.1 Newton into SF. Okay, so yeah, this is by solving with Lami's theorem. So that's why you can see in this question, Lami's theorem is actually easy. Okay, why is that so? Now let's try to do resolving. So just to say that Lami's theorem, it will be easier, right? If let's say the question straight away give you like in this term, so which means you can actually see the angle obviously like very clearly, and after that you have like a pair that you already know that if let's say the unknown is as is in a pair where you already have one of the information, like what you have in this case, like you want to find alpha, then you have 40, then you have one complete pair which is 50 and 120. Okay, so but yeah, I mean either way we can still try to do resolving as well. Okay, so let me try to use another color here to solve by resolving. Okay, so which means I want to show you two different way of resolving this question as well. The first one is we try to do the normal one. Okay, so the normal one, which means I will try to resolve it in the x direction and also y direction, right? So let me just try to draw a line. Okay, so yeah, we might need to do some easy trigger to let us to find some of the angle that we need. Okay, so in this case, I have 120 here, so that's why I know that this will be 30. Okay, if this is 30, which means this will be 60 lah. I mean, you do not need this as well, except you want to do F cos 30, F cos 60 lah. It's just the same. Okay, then after that, you might have a problem over here. So how are you going to find this? Because eventually you might need this value that only you can resolve 50, right? So yeah, if let's say you want to find here, then it will be hard also because you do not have the unknown here. Okay, so the thing that you can try to do is either you already know this is 60, so that's why this point it will be alpha minus 60. Okay, so the other one, if let's say you want to deal with this, then which means that this angle, it will be 180 minus 30 minus alpha. So which will give you 150 minus alpha. Okay, so it will depends on you which one you like lah, but yeah, basically they are just the same. Okay, so let's try to resolve it. So yeah, resolve to the direction of x. Okay, so what I have here is f cos 30. Okay, and then it will be equal to 50 cos 150 minus alpha. Okay, so yeah, this in this equation you have two unknown, so basically you can't solve it, so you can just leave your answer first. Then resolving to the y direction, then what do we have? We have 40. Okay, and then it will be equal to your f. So I know that you have a choice here. Either you can do f sine 30, or you can do f cos 60. But in this case, you can try to imagine what will happen next is it will be good that we can just use tangent to solve, right? And for you to have tangent, actually what you need is that you need to have sine over cos, and it's like sine 30 over cos 30, then it will can only be tangent 30. So you imagine if let's say you try to write f cos 60 here, then later you have a problem when you try to solve your simultaneous. So that's why in this case we try to keep the sine 30. Okay, and then after that it will be plus, and the other one is 50, and then we can just try to use the same thing as well, sine 150 minus alpha. Okay, so by having this, then maybe I'll need to rearrange this a bit. So I will have f sine 30 is equal to 40 minus 50 sine 150 minus alpha. Okay. Okay, so when you reach this point, right, this is your first equation and this is your second equation. So let's try to imagine what happened later is normally like what we try to do is we use second one to divide the first one, right? Then after that we eliminate our f, then our sine 30 divided by cos 30, it will give us tangent 30. And then now your problem is with your right hand side because you have this 40 minus thing, then what happened here is you couldn't actually do the sine divide by cos theta. So it will actually cause you to have a very difficult journey when you try to solve this simultaneous equation. So that's why in terms of resolving, I'm going to introduce you another way to actually do your resolving. So yeah, I'll just stop it here because I don't think it's very efficient way to actually do this. So that's why let's try to change the other color, and I want to show you the way that I want to show you for the resolving part. Okay, so by having in different direction, you'll realize that you do not have all this calculation anymore. Okay, so the idea is same thing. You might want to remember that when we try to talk about forces in equilibrium, right? So which means that the forces in the component in that any direction will be zero. So it's the same thing like how we deal with the example one, the extra question. It's the same idea. So the question that I try to ask myself is there any direction that after I resolve, I can actually get an equation with only one unknown so that I do not need to deal with simultaneous equation and I do not need to deal with so many, like for example, 150 minus alpha and so on. Okay, so by looking at this, right, we know that the forces when they are perpendicular to each other, like for example, if let's say I try to resolve in the x direction, then I don't need to take into the consideration of 40 Newton. Am I right? So I'm just going to resolve the F here and I resolve the 50 here. Then when I try to do the vertical, then I only look at the 40. So by using the same concept here, so which means that can I actually resolve my force in the direction of F? So you can imagine if let's say I try to resolve it in the direction of F, right? Then when I try to resolve it in the direction perpendicular to F, then what happened here is that I do not need to take into the consideration of the F force anymore. So that's why I can focus in actually solving my alpha first. Because F actually contributes zero forces to the direction that's perpendicular to it, right? So that's why by having this, I can actually solve my first unknown first, which is my alpha. Okay, so let's try to do it. So resolve in the direction, sorry. So resolve in the direction perpendicular to F. Okay, so which means what we have here is just by looking at the two force, which is the 40 Newton and 50 Newton. Okay, so similarly, we have 120, right? So that's why if in this direction and this is perpendicular, which means this is 90. So that's why by just doing some simple calculation and we can get 30 here. Okay, so how about this one? So yeah, we can always use the angle here. So this is 180, then minus alpha. So you can realize that here that we have only one unknown, so it's just 40 cos, it's cos, right? Yeah, 40 cos 30. Okay, and then it will be equal to, yeah, so remember to look at it nicely, because you want this, so this sign is touches this angle that you have, so it's 40 cos 30. So in this case, it's the same thing. So from here, so 50 is not touching this line. So sorry, this angle is not touching this line, so that's why this should be 50 sine. So it's equal to 50 sine 180 minus alpha. Okay, so now we have only one unknown, so we can actually solve it. Okay, so sine 180 minus alpha is equal to 40 cos 30 divided by 50. Okay, so similarly, let's use the calculator. So shift sine and then 40 cos 30 and divide by 50. Okay, so I'll be able to get 43.85. Yeah, so same thing, you might want to check on your calculator again. So because to make sure that the number that you write is either in quadrant 1 or quadrant 2. So by looking at this diagram, then you know that 180 minus alpha, it should be a quadrant 1, right? It's less than 90 degrees, so that's why 43.85 is correct. Okay, so 43.85, so we can just write down 43.85 first. Okay, so by using 180 to minus it, then we'll be able to get our first value, 136.1 degree, and this is 1 dp. Okay, so same thing, you can try to check and see whether you get the same answer or not just now, so you can see your answer is correct. Okay, so now let's try to move on to the next one. The last one is the f. So now by using the f, then we need to resolve the other side lah. So which means resolving in the direction of f. Okay, so now we have f will be equal to, so move towards the other side. So this is 50 cos, the answer we get just now. 50 cos, yeah, remember it's this value, not this value, so 43.85. Okay, and then plus the other one up there is going to be 40, then sine 30. So plus 40 sine 30. Okay, so by putting everything in your calculator, and you should be able to get 56.1 Newton, so which is in 3SF. So it's the same answer that you get from the Lami's theorem. Okay, so this question is to just demonstrate to you that it's important for you to understand that when you try to resolve the component, it doesn't need to be always in the direction of x or y. Okay, so that will be easier, because if let's say this question I try to just change it a bit, then if your f is like here, then everything will become easier already. But now is that what you have is like the 40 here, and then after that your f isn't in the direction of x direction, so that's why it will be easier that for us to actually try to think of, is there any direction that actually can allows us to actually solve one unknown first before we get to the other. Okay, and the idea is, remember that it doesn't need to be in x direction, y direction. So as long as you have a perpendicular direction, then after that in forces in equilibrium, is no matter you are resolving in which direction, the resultant will always be zero. Okay, so that's the idea. So I hope that you can understand and spend some time to do your homework. So if you got any question, then please approach me personally. So that's it for today's session. Thank you.